My name is Ted O'Brien. I'm a web developer and an instructional designer. I've also worked as a teacher. I've taught JavaScript, ESL, linguistics, high school math, and geography. I've worked for public and private schools. I coded HTML pages for an online magazine in San Francisco before I became the JavaScript programmer for a branding agency. I've also worked as a freelance web developer. At two of the schools where I taught, I administered a Moodle course management system. I used it to assess English fluency and to give math exams. I still use Moodle installations for the registration and login components of my apps. I consider myself primarily a front-end web developer. However, a lot of my apps use PHP pages that make queries to MySQL database tables. The jQuery app that I made this presentation with, called JPlayer, is an object-oriented program. I was able to modify it to limit which slides the dots on the progress bar correspond to. However, when I code my own apps, I only use the procedural approach in both PHP and JavaScript. I once hired a Russian developer using Upwork to help me with PHP CURL functions. I created my GitHub page to learn new skills by modifying the code from other GitHub repositories. Most of the websites I developed as an employee or freelancer no longer exist. That's why my skills are best illustrated by my own websites. These three sites, Graphic History, Earth and Sky Camp, and Physical Facts, complement each other in helping students to learn history, geography, and physics. The Earth and Sky Camp app is the most complete. Graphic History and Physical Facts are still under construction. Color-Coded English is the app that I've spent the most time developing. I recently modified it to help early readers, but I originally used it when I taught English as a second language. I later developed an online game show called Someone Said, based on the multiplayer game that I used in the classroom when teaching ESL. I made a couple of pilot videos of Someone Said, but I would need to hire an Upwork developer to complete this app. I'm making this presentation in part to try to persuade teachers and homeschoolers to use Earth and Sky Camp or Color-Coded English. This would make the apps more attractive to potential investors and partners. All of my apps are for sale, and I am open to any arrangements that would get more students using them. Organizations like All4Ed are committed to expanding equitable educational opportunities for students from low-income families. They promote digital learning solutions through their framework for future-ready schools. My apps can help address the homework gap that future-ready schools and their corporate sponsors and community partnerships want to fill. There are also many private online education services which might like to add one or more of my apps to their programs. Other than the Someone Said game show, all of my apps provide hands-on learning activities for students. These include quizzes, drawings, and games. The apps also use memory devices to maximize the knowledge that students retain from these activities. An example of a memory device is learning the phrase, "Every good boy does fine," in order to remember which notes correspond to the lines on sheet music. That is an example of chunking. The use of common phrases to learn vocabulary is how chunking is used in color-coded English. Memory palaces, or memory theaters, were widely used before the invention of the printing press. A Greek poet who recited long poems is credited with making this visual device popular. Memory theaters were called the method of loci by the Romans. They located information in a mental image in order to remember it. Manual memory devices use the segments of your fingers as a mental image to remember information. Graphic history uses 20 finger segments to make its chronologies mnemonic. The word mnemonic means memorable. The segments are numbered 9 to 0 on your left hand and 0 to 9 on your right. This works the same for decades, centuries, and millenniums. Type 1 grids on your left hand are used for before Christ and before the present chronologies. The right hand is used for common era chronologies. Note that there was no year 0, and the last year of a common era decade or century actually ends in 0, not 9. But this format is simpler and recursive, meaning it repeats for different exponents of 10 years. This is an example of a mnemonic century. The 19th century is part of the Common Era, so it uses the Type 2 numbering system on your right hand. Note that there are images in each cell of the table. It's easier to first associate finger segments with images before associating them with text describing events. All centuries link to the millennium of which they are a part of, and to the previous and next centuries. Recent centuries also have links to each of the 10 decades that they contain. Looking closer at the last 4 decades of this century, we can see that the text also links to other pages. These are mostly links to Wikipedia articles and YouTube videos. This is the chronology for the 1960s decade of American movie history. The text links to Wikipedia articles about these Best Picture winners, and the play buttons link to movie trailers on YouTube. Chronologies of popular musical recordings that you can listen to on YouTube will be added in the future. The graphic history quizzes reinforce your associations of events with finger segments because you click on one of 10 cells in a grid to answer the questions. History teachers know that there are limits to the number of dates students can memorize, so they typically don't focus on dates. However, the numbers in dates are somewhat arbitrary and have no intrinsic relationship to events. Mnemonic chronologies, on the other hand, enable students to visualize sequences of events in a structure, revealing the context in which they occurred. This can help students to better understand events and explore related information. I believe the potential appeal of graphic history is in producing videos about individual decades and centuries that summarize and compare online articles and videos about events that their chronologies link to. There are thousands of interesting and well-produced videos about recent and ancient history on YouTube. The Earth and Sky Camp website is based on a student atlas and map sketching program that I produced when I earned my bachelor's degree in geography. I drew the maps in the atlas with Macromedia freehand software. It was sold to Adobe, and their own vector graphics software, Illustrator, no longer opens freehand files. Fortunately, I found a freeware vector graphics program that opened the pages in the PDF of my atlas. I changed the name of the expandable map to the manual map. I was motivated to make the app when I discovered that the JavaScript Canvas object could enable students to perform the atlas's map sketching activities on a laptop. There were 24 maps in the atlas, and they can all be displayed using the app's control panel. The Earth button displays the world map, and the buttons on its right side will display the northwest, northeast, southwest, and southeast sections of the world. The 16 buttons below them display the most detailed maps. There are also north and south polar views and one sky map. The primary 24 squares of the manual map can be associated with the 24 segments of the 4 fingers of your left and right hands. You start by associating the first 24 letters of the alphabet with these squares. Each square is 60 degrees wide, and the 6 columns span 360 degrees. Each primary square is divided into 4 major squares. The numbers always flow left to right and top to bottom. Major squares are 90 degrees wide. Each major square is similarly divided into 4 minor squares. Minor squares are 15 degrees wide. The Earth rotates 15 degrees every hour. 24 hours times 15 degrees per hour is 360 degrees. Primary squares are divided into blue and red zones. Associating an area with blue or red will help you to remember which half of a segment the area occupies. When your hand is flat, your finger segments will not line up to connect the meridians between squares, but they will if you curl your fingers. They also appear more square. Think of the minor squares as seats in a theater. Seats are typically grouped by sections, rows, and a number. There are 384 minor squares on the map. If you have associated the letter C with the outer segment of your left index finger and know how the numbers flow, then you can easily determine where square C4.4 is. Most of the British Isles are located there in the bottom right of the C square. The land east of London is located in the D3.3 square. It takes some practice to remember where each letter is, but after you've located famous places around the globe using the blue and red colors with the square numbers, you will find it fairly easy to associate major or minor squares with places. There are several camp activities for students. They include sketching maps, making basketball globes, exploring cities by pointing at them to view photos, and clicking on them to read articles and watch videos. However, it is the sketch mapping activities that will best prepare students for the map quizzes. This is because drawing a coastline requires you to carefully observe it. Seeing how accurately you have drawn a coastline fixes it more firmly in your memory. You can use the map's straight, black lines of longitude and latitude with the drawing by squares method. The Egyptians were using the same method almost 4,000 years ago to make large drawings and sculptures. When you select Sketch on the control panel, it will display either the west or east side of a map, so you can copy the 15-degree wide squares that make up the primary squares. You should then locate cities using the dot tool and label them with the text tool. Notice that some of the crosshairs are made with thicker and darker lines than others because they help you to remember positions of coastlines. The control panel enables you to download your sketch maps to your computer. If you are logged into an account, you can upload your sketch maps to your personal map page. The app will combine your uploaded maps into 2 world maps, one for the 180-degree wide maps and one for the 1690-degree wide maps. The app will display the most recent maps you have uploaded, so you can revise your world maps by redrawing and uploading their sections. The thick crosshairs displayed in sketch mode are the key to learning to sketch world maps on physical surfaces. Note that the center crosshair in primary squares is always used when sketching the manual map. Crosshairs that correspond to the corners of the 15-degree wide squares are included when they help you to locate coastlines. This is how you can sketch maps on a chalkboard. You use your natural sense of symmetry to draw 2 180-degree wide squares. Then you divide them into thirds, which are 60 degrees wide. Then add the useful crosshairs. You can use a smartphone to copy the squares, but after you've sketched several chalk maps, it becomes easier to draw more and more of the map by memory. If you use green chalk for the grid, the white coastlines will stand out more clearly. Students don't need to memorize the manual map in order to use it to study geography. In teams is an activity students can do together while seated at their desks. 4 to 8 students can be grouped into teams and given photocopies of 6 by 6 grids of squares. If each square represents 15 degrees of longitude, one sheet represents 90 degrees. Teachers can download a printable PDF of this grid from the gallery page. Students must cooperate with each other in order to combine their drawings into a world map. Teachers will have to offer more help and supervision to some teams than to others. The manual map can also be expanded with sheets of butcher block paper. The best place to do this is in a cafeteria where students can work around big tables. Yardsticks are needed for making grids on the 36-inch wide bands of butcher block paper. The grid is drawn in pencil and so is the map. However, markers are then used to draw the map's coastlines and borders. This activity will take more than one class period. Once you start looking, you will see lots of grids of squares already made. The overlapping cinder blocks in many school walls form square grids. You can make maps on them with art tape and have teams of students take turns taping drawings and text onto the wall to make presentations about a variety of subjects. The Global Education Futures Organization promotes the study of environmental and ecological issues that students could report on with drawings and short essays on wall maps. Several classes of my students used large pieces of sidewalk chalk to work together in sketching a large map on the school's stone courtyard. Copying the manual map onto a basketball is the ultimate manual mapping activity. It gives students the best reference for further development of their mental maps, and it also reveals a lot about how the geometry of two-dimensional maps relates to our three-dimensional planet. Basketball globes can be made with either Sharpie ink markers or acrylic paint markers. In addition to a basketball, other necessary materials include cardstock guides, a crayon, a sharpener, pencil erasers, rubbing alcohol, and paper towel. You start making a basketball globe by using a crayon to draw a grid of 15-degree wide squares between the black seams. The 2 cardstock guides in each globe kit have lengths that are half the circumference of the ball. There are 2 common sizes of basketballs. Size 6 is used in women's basketball and for middle school students. Size 7 is the regulation size used in the NBA. The process of using the guides with a crayon to make the grid of 15-degree wide squares on a basketball is presented on the Earth and Sky Map Camp website. These crayon lines reveal that the primary squares of the manual map are not actually very square. The top and bottom rows of primary squares are actually triangular. However, when the 16 minor squares within each primary square are drawn, you can see that they do form a gradicle of square-shaped quadrangles. Minor squares are all the same size on the map, but you can see that they actually decrease in size as they approach the poles on a sphere. The study mode of each map has a globe view that shows where the black seams of the basketball will occur on the map. The coastlines of the polar areas are highly distorted on the manual map projection. You need to use the 2 maps for the north and south polar areas to draw these coastlines on your globe. Note that you will mark over the crayon grid lines on continents with a Sharpie marker, but you will need to erase crayon lines in the oceans after you locate cities on your globe. You mark over the crayon grid lines in the oceans with an acrylic paint marker and similarly need to erase crayon lines on the continents to finish a globe. The sky map is similar to the world map. The declination of stars is similar to degrees of latitude, but longitude is replaced with hours of right ascension. There are 4 hours of right ascension in each of the primary squares. The line that curves above and below the celestial equator indicates the path of the sun, moon, and planets. Their current positions are shown with different colored circles. It takes 1 year for the yellow sun to move across the width of the map. The sun is approaching the summer solstice in this screenshot. If you select months on the control panel, you can see the approximate position of the sun for any date. East and west are reversed on the sky map. After the sun sets, you can see the stars and planets to the left of the sun. This is the sky to the east of the sun as it sets in the west. Star globes are made the same way as Earth globes. The best results are made with black or blue balls. Which ball you choose will determine the colors of acrylic paint markers you will need. Star globes provide views of the sky that are similar to online star charts, like the one at skyandtelescope.org. The sky map is not as precise as the star charts in showing the positions of the planets and moon. The advantage of the sky map is that you can memorize the positions of stars and know which ones will appear after sundown based on the date and the corresponding position of the sun. Note that anyone can upload photos of maps on physical surfaces or basketball globes. Make a globe by copying the squares using your smartphone, and then take a photo and upload it. It will appear in the camp gallery after it has been approved. I think my Earth and SkyCamp app has the greatest potential appeal because it provides cooperative learning activities that can help motivate students and make teachers' jobs easier. Future-ready schools advocate community partnerships and corporate sponsors. Note that logos can easily be positioned in the Pacific Ocean on globes so they won't interfere with coastlines. Universities could be persuaded to donate basketballs with their logos printed on them. They would be given to students who have demonstrated their ability to make globes by uploading sketch maps. This would contribute to the future-ready goal of helping low-income high school students prepare for college. My Physical Facts app is intended to help students explore the relationships between energy and matter. It uses a memory device similar to the manual map for the periodic table and devices similar to the graphic history chronologies for energy, frequencies, and distances of both energy and matter. Note that 3 of the segments on your index fingers, B, C, and D, are not associated with any elements, but the letters Y and Z are associated with the inner segments of your thumbs. The numbering of the letters is also different. On the manual map, there are 16 minor squares for each letter, but there are a maximum of 6 elements for each letter on the table. The first number following a letter refers to its row. Rows correspond to the 7 periods. The second number following a letter refers to that element's position in its row. For example, J4.2 and J5.2 refer to elements copper and silver, and P6.2 refers to gold. They are all in group 11 of the 18 groups listed along the top of the table. Note that Y and Z only contain 1 element. The letters A and X each contain 4 elements, and S contains 2 elements. This is a common view of the periodic table with the atomic number shown above the symbol for each element. Atomic numbers refer to the number of protons in the nucleus of each element. Pointing at a symbol or atomic number displays the name of the element, and clicking on it opens a new tab with a Wikipedia article about it. The actual sequence of the elements by atomic number makes the table less readable, so the lanthanides and actinides are usually shown below the other elements. Lanthanides make up most of the rare earth metals. Elements with the same background color are called element families. Elements in the same families have similar physical properties. Note that most of the element symbols have black text, but most of the 7th period elements have brown text. Brown means these elements do not exist in nature. They are synthetic and that they are made in laboratories and are typically unstable. There are 5 liquid elements indicated by blue text and 10 gases indicated by green text. The period numbers of 1 to 7 correspond to the number of electron shells in an element. For example, hydrogen and helium have 1 shell. Period 2 elements have 2 shells. Remember, cells J4.2 and J5.2 refer to copper and silver. Copper is a 4th period element and has 4 shells, while silver has 5 electron shells. The concentric circles to the right of the table indicate that the radius of an atom increases with the addition of a new shell. However, as the number of electrons increase in those shells, corresponding to the number of protons in the nucleus, the radii of the atoms actually decrease, moving from left to right in a row. Also note that the first atomic model by Niels Bohr in 1913 proposed that electrons orbit a nucleus like planets orbit a star. The modern atomic model refers to the locations of electrons in atoms as orbitals. Orbitals are not completely understood, but they are still commonly represented as orbits in simple diagrams. This is a diagram of the 6 shells in an atom of gold. Gold has 79 protons and 79 electrons. Shells correspond to energy levels of electrons. The further a shell is from the nucleus, the greater is its energy. Shells have subshells that also correspond to different energy levels within the shell. The subshells are designated by the letters S, P, D, and F. All shells contain an S subshell. The second shell also contains a P subshell. Shells 3 through 7 all contain S, P, and D subshells. Shells 4 and 5 also contain F subshells. There are 32 elements in the 6th period, and gold is the 25th. But it only has 1 electron in its 6th shell. It is the green S electron at the top of the diagram. The orbital blocks view of the table reveals why this is. S-block elements are colored red. The S-block is the first subshell that electrons fill. Every 6-period element from barium to iridium has 2 electrons in its 6th shell. Gold is a blue D-block element because starting with element 71, elements begin to fill the D subshell in the 5th shell with electrons. The lanthanides are green F-block elements because they are the first to add electrons to the F subshell in the 4th shell. The 6 yellow P-block elements following gold and mercury are the first to add electrons to the P subshell in the 6th shell. Radon has 2 S electrons and 6 P electrons in its 6th shell. All of the noble gases in group 18, except helium, also have 8 electrons in their outer shells. Copper and silver, which are like gold in group 11, also have only 1 S electron in their outer shells. And the elements to their right first add a second S electron before adding 6 P electrons. 8 electrons in the outer shell is the most stable electron configuration, and it's why these elements are inert and don't form compounds with other elements. This repeating progression in atomic structures raises the question of how elements are formed. The radiation emitted from stars is primarily due to the fusion of hydrogen into helium. Gravity is the force that initially fuses hydrogen. Average-sized stars like our sun Also eventually fuse helium into period 2 elements like carbon and oxygen. Stars vary in the amount of hydrogen that they begin with, and this determines how they will evolve. After most of the hydrogen has been depleted by gravitational fusion, the remaining hydrogen is fused into helium in a thermonuclear process. This causes the average stars to expand into red giants and massive stars to become red supergiants. Eventually, red giants collapse into white dwarfs, and collapsing red supergiants explode into supernovas. Depending on the initial mass, the cores either collapse into neutron stars or black holes. The Sky Map uses Hertzsprung-Russell diagrams to provide students with basic information about stars. Pointing at the brightest star, Sirius, on the Sky Map will display this diagram. The text below the diagram reveals that Sirius is only 9 light years away, which, as the second closest star, explains its relative brightness. The x-axis of the Hertzsprung-Russell diagram is based on temperature, and the y-axis on absolute luminosity or brightness. We can see stars that have much higher absolute luminosity, but they are much further away and appear dimmer. All stars begin on the main sequence curve, which stretches from the top left to the bottom right in the diagram. The sun is shown on all the diagrams as a yellow dot with a luminosity of 1. Sirius is actually a binary star. It's actually a white dwarf and a massive blue star orbiting around their common center of gravity. Our sun will eventually leave the main sequence to become a red giant before collapsing into a white dwarf. Sirius's main sequence star has 1.7 times the mass of the sun, so it will evolve into a brighter red giant than our sun will, but it is not large enough to become a red supergiant or a neutron star. Note that neutron stars don't emit enough heat energy to appear on these diagrams. With that information, you can understand the theoretical origins of the elements, which is called stellar nucleosynthesis. The backgrounds of the table cells correspond to the 6 processes listed above the table. The elements without backgrounds are synthetic and only occur on Earth when they are artificially produced. The heaviest elements are green and yellow, indicating they were formed in merging neutron stars and small dying stars. Blue elements are the result of large stars exploding, and orange elements are formed when white dwarfs explode. Note that element 43 is synthetic, and so is element 61. The heaviest elements from 93 to 118 are synthetic as well, but they are radioactive. The instability of element 43, technetium, is most likely due to how protons and neutrons combine in the nucleus. Some elements are only stable when they contain more neutrons than protons. These are called isotopes. Technetium has no stable isotopes. It is important to realize that it is not necessary to understand everything about atoms in order to benefit from studying the periodic table. Many products and services in our industrialized economy depend on chemical processes, and basic information about them and their related technologies increases awareness of economic opportunities. That's why there are hundreds of websites and videos where you can study chemistry. It's also important to understand that we and everything else on Earth are stardust. The trillions of atoms inside us were all formed by stars. We are all a part of an immense and evolving universe. There are 5 grids for showing the sizes of things using exponents of meters. 2 of the grids have negative exponents for fractions of meters. These are similar to the type 1 chronologies which you associate with your left hand. The other 3 grids with positive exponents are like the type 2 chronologies associated with your right hand. Their distances range from atometers, or 10 to the minus 18 meters, for showing the size of an electron, to 1,000 yotameters, or 10 to the 27th power, for the theoretical diameter of the observable universe. Note that the type 1 negative exponential grids are not as simple as type 1 chronologies. For example, the outer segment of your left index finger is associated with 10 to the minus 6 meters. This represents 1 micrometer. When you click on the 10 to the minus 6 link to see how visible light wavelengths vary, the micrometer cell leads to a type 2 positive continuous grid for hundreds of nanometers. The positive 600s of nanometers are associated with the outer segment of the ring finger on your right hand. 3 positive exponential grids are used for studying energy frequencies. They are all positive exponents ranging from 1 hertz to 1 million exahertz. The type of radiation listed ranges from delta brain waves to sound waves to visible light to gamma rays. Note that higher frequencies of radiation correspond to smaller wavelengths. The quizzes for physical facts are currently limited to locating elements in the table based on their name. You can select the periods of elements in a quiz. The elements in the first 3 periods are the most common, so they are the subject of the default initial quiz. I plan to add more quizzes. However, the app first needs to enable students to study an aspect of chemistry if it is going to offer quizzes about it. There are also many great chemistry websites that I will list on a useful links page, and there is no reason to duplicate what they already do. Physical Facts is an annual memory app. It presents information that complements Earth and SkyCamp, and I think it also has the potential to complement middle school textbooks and websites about chemistry and physics. Color Coded English is the website I have spent the most time developing. It has apps for studying phonics, vocabulary, and grammar. It contains a topical dictionary called the Word Map, which is similar to the manual map in having 24 topics that can be associated with your fingers. The word map illustrates how words provide a model of the reality we experience. However, the main memory device for acquiring vocabulary is chunking words together in their most common phrases. The importance of acquiring a core vocabulary of the most common words is critical for early readers and ESL students. Oral English is simpler than written English and does not use nearly as many different words. After acquiring 5,000 words, students can typically learn additional words on their own from dictionaries. However, if they fail to master these words in the first years of school, they tend to lose interest in reading or learning English as a second language. The app's activities involve both listening and reading, along with puzzles, quizzes, and games. The selection of words in the word map is based on a list of the 5,000 most frequently used words. The list was created by the Corpus of Contemporary American English, using 450 million words from mass media publications and transcripts. The most frequently used words like the, be, and of are positioned first. The position of words in the list is the basis for grouping them into 4 levels. Bold text indicates the most common level 1 words. Level 2 words can be identified by bold italic text. Level 3 by italic, and level 4 by plain text. The name of the website is based on its grammatical color code. Teaching grammar is a controversial issue because people learn grammar intuitively in their first language from whomever they begin speaking with. However, non-native speakers will initially try to use the grammar of their first language and translate sentences word by word. Moreover, the grammatical proficiency of a native speaker is not directly related to their grammatical literacy. In other words, they don't make grammar mistakes, but it's not because they can identify parts of speech and parts of sentences. I created a grammatical color code because I believe that grammatical relationships could be revealed with cascading style sheets. Because phrases and dependent clauses also form parts of speech and parts of sentences, I later realized that color-coded parentheses, braces, and brackets were also needed. Parts of speech and parts of sentences are directly related to the meanings of words. A word's meaning can change based on how it is combined with other words. The color code was also a way of branding the website. Color-coded English contains puzzles and quizzes for learning phonics, vocabulary, and grammar. All of the content can be viewed on either a laptop or a smartphone. Phonics skills are fundamental to reading. With the spell checker quiz, students can choose the number of letters and words before hearing them and then trying to spell them. After the words are correctly spelled, they are pronounced again and listed below. The parts of speech of the words are indicated by colored underlines and by colored squares. Note that I used a third-party text-to-speech app to generate the audio files for the words and letters. It offers voices with different accents and ages. I use the voices of children to pronounce the letters of the alphabet when they are clicked. The core activities of color-coded English are combining letters into words, combining words into phrases, and then combining words and phrases into sentences. Common phrases are called collocations. Words of different parts of speech combine together more frequently than other words. For example, in English, the phrase fast food is very common. In Chinese, they use the phrase fast meal. The corpus of contemporary English, which provides the basis for selecting and dividing the most common words into levels of frequency, also identifies which words combine with other words most frequently. The most common words like the and of are not included in the topical dictionary. These structural words are listed in a sight words puzzle and or the color-coded grammar charts. They can't be learned in collocations. Irregular verbs also cannot be taught with collocations, but are grouped by types in the PDF grammar charts. There are 4,320 words in the word map topical dictionary that can be learned with collocations. This is a screenshot of the map's 24 topics when viewed on a computer. Clicking on one of the 12 groups within a topic displays 15 words to the left of the word map. Clicking on any of these words then displays the word above the map and in 3 of its most common phrases. Clicking on a topic title displays all of its words. There are also options for what you want to see displayed next to a word. A simplified Chinese translation has been selected in this view. Another option for what is displayed next to each word is IPA. An International Phonetic Alphabet pronunciation follows each word in this view. The icons above the table allow students to either listen to phrases or view them in text or image searches. Note that bold and italicized text reveals the level of words. Students can use the buttons to the left of the list to view words by level. Some students might already know most or all of the level 1 words and can begin by studying level 2 or level 3 words. Note that all of the website's pages are simpler on smartphones and tablets. But whether you are using a laptop or a smartphone, you will always hear the pronunciation of a word when you click it. And the default setting is to hear the pronunciation of phrases when you click on them. Clicking on the word before the phrases displays its definition in dictionary.com. In addition to viewing the IPA pronunciations next to words, there's an option to view the date and source of its origin. Words like good were used in Old English before the year 900. After Latin missionaries created written English, the number of English words began to steadily increase. Clicking on the dates of word origins will display a word's entry in etymonline.com. This is an etymology website that gives a brief account of how and when a word came to be part of the English language. Spanish and Chinese ESL students can view translations to the right of English words. After a translation language has been selected, a translation icon will also be displayed to the right of the pronunciation icon. In this view, it's the two arrows inside a blue square. When the translation icon is selected, clicking on phrases will display Google translations of them. After listening to words and phrases and exploring their meanings, students can reinforce their understanding of them in phrase matcher quizzes. Students attempt to match one of 5 words with the blanks in 3 phrases. More than one of the 5 words may be a match for 1 or 2 of the phrases, but only one word can replace all 3 blanks. For example, the word sleepy kind of fits in the first and second phrases, always sleepy and get sleepy easily. But it doesn't make sense in the last phrase, sleepy of being. The word tired works in all 3 phrases, always tired and tired easily, and tired of being. The score is based on the percentage of correct matches. You get 20 seconds to answer each question. The unused seconds are divided by 10 and added as a time bonus. There are 24 questions in each quiz. One word is randomly selected from each topic. The words are listed at the end of the quiz, and the solid and empty squares next to them indicate which words were matched or missed. You can click on words to review their phrases. You can also control which of the 4 levels of words that you want to be quizzed on. However, if you don't change the level, 1 or 2 of the questions might be asked again in the next quiz because the words are selected randomly. I originally designed the phrase matching activity as a homework activity. The Moodle Login again provides a system for tracking student progress. Anyone can create an account using a valid email address. After clicking the link, which will be sent to your email, you can log in to an exam with your username and password, which your device can easily save. The exams start with level 1 words in topic number 1. Students can change the level of exams at any time, but the topic of an exam is always based on the last exam taken in that level. There's also a prepare link that can be clicked before an exam has been started. There are 15 questions in each exam, and there are 45 words in each level of a topic. The format of exams is the same as the quizzes. Exam scores, like the quizzes, are based on the percentage of correct matches and a time bonus. At the end of an exam, its 15 words are displayed with the same full and empty squares to indicate which words were matched with their phrases. Clicking on the words will similarly display their phrases. A link to the next exam topic is also displayed at the top. Laptops will display the next topic exam preparation page with the 45 words for a level in 3 topics. The gray background and white text of the people topic indicates that its words will be on the next exam. This is the view students will see if they are preparing for exams on a smartphone. All 45 words in a level are displayed for one topic. When students or parents are logged into an account, they can see the results of all the exams a student has taken by clicking on the My Scores button. Again, solid squares indicate matched words and empty squares with colored outlines indicate missed words. However, you need to click on one of the 12 groups of squares in a topic to see the words. This is the My Scores view on a smartphone. Words without squares have not yet been tested, so this view is also useful for exam preparation. Teachers can also use the app to see which words their students are failing to match, and then use the PhraseMaster classroom game to review them. The format is similar to the quizzes, but the class is divided into 2 teams, and team members take turns trying to match words with phrases. The game provides a fun and productive way to end the class when teachers finish their lesson plans 10 to 15 minutes early. I developed a synchronized multiplayer version of the game when I taught ESL in China. The red and yellow rectangles on the left and right side of the screen are buttons for selecting students who would pick a square and then try to answer its question to score points and potentially a 3-in-a-row tic-tac-toe bonus point. The white plastic object on the top front of my desk is a portable Wi-Fi device that eventually enabled all the students to connect to the app with their smartphones. Note that students now, and even 8 years ago, were not allowed to access the internet on smartphones. The schools where I taught allowed me to occasionally use this game in the classroom because I was a popular teacher who created fun, communicative lesson plans in my other classes. Foreign teachers typically aren't allowed to assign homework in ESL classes. The main responsibility of foreign teachers was always to provide fun activities for using English in the classroom. Most students did not have much fun playing this game. It was basically a type of group exam. Other than reading the phrases with their chosen word, it was not a communicative activity. I designed a much different game later that is communicative. It relies on the natural motivation for students to ask and answer questions, to get information from each other, to score personal points. Students are not divided into teams. This app requires students to be connected on their smartphones, but they don't have to be in a classroom together to play. This app would be useful for homeschoolers to connect and socialize with like-minded students. It can also be used by small private bilingual ESL teachers in foreign countries to attract students. I hope to eventually get financing to hire Upwork freelancers to develop it. I'll need help with AI and WebRTC. RTC stands for real-time communication. Reading skills are complemented by writing skills. In the probable cause sentence puzzle, students click on words to position them correctly in a sentence. The first word is given, and after 3 words are positioned incorrectly, they are automatically removed. Students can also click the check button at any time to remove any incorrectly positioned words. They have 60 seconds to complete the sentence. They can still attempt to position words when the time is up until they click the Give Up button. The completed sentences are color-coded. This reveals the grammatical structure of the sentence and why the words are positioned as they are. Many of the sentences are based on quotes and proverbs, and some have been around for centuries. If a quote has a known author, clicking on the search icon will open a search for the name. The multiplayer PhraseMaster game that I abandoned was based on a script for an Ajax group chat game. I later modified that code to create an app for producing an online game show. The show is called Someone Said. 4 players take turns attempting to unscramble quotes the same way they do in the probable clause puzzle. Then they try to match them with their authors. The SomeoneSaid.tv website has a daily single-player version of the game. There are short biographical introductions about the authors at the start of the game. This provides a basis for matching quotes with their authors after a quote is unscrambled. In the game show pilot videos that I made, all of the participants were connected to a web server using jQuery Ajax functions. The participants were also connected with me on a Skype call so that I could capture their audio. I acted as both the host of the show and the operator of the app. but the app design allows a professional entertainer to be the host with a separate operator. The operator records a game with video software like Camtasia. In this prototype app, audio and video were added in post-production. To keep the production simple, I used still photographs for the players, but Camtasia made it easy to add video of myself as the operator host. The operator uses the blue and red player name buttons to determine which two players will be attempting to unscramble each quote and match it with an author. The host and operator both see the progress of two players trying to unscramble a quote. The views that the players see are not the same as the host. Teammates only see the progress of their fellow teammate, but they also see the number of words correctly arranged by the other player, as well as the remaining time to complete the quote. The host will occasionally prompt teammates to offer suggestions, but clicking on the words on a teammate screen has no effect in ordering the words. Teammates also see the first choice of their teammate in identifying the quote's author. If it is not correct, they can offer their opinions about the final second choice. The blue and red teams claim squares in the tic-tac-toe grid of quote authors based on how many words they unscrambled and whether they correctly identified the author in their first or second attempt. Ethan claimed Carlos Santana for the red team, but Mark and MP tied on the Evel Knievel question, so it has a purple border. Purple squares can be claimed by either team in 3-in-a-row bonuses. WebRTC is a technology that would make the game show much easier and cheaper to produce. Most modern web browsers use this technology to support video calls of up to 6 participants. I documented the code that I used to produce my prototype videos, along with my understanding of how WebRTC could be used to add video for all of the players. WebRTC is also used for chat text during video calls, so it could probably also replace the AJAX queries that I used and reduce latency. The potential appeal of Someone Said is related to the thousands of great quotes that I have collected, the diversity of their authors, and the difficulty in matching them with their quotes reveals our common humanity. Note that a significant percentage of the quizzes are translated into English from other languages. Using college students as players would also add to the show's appeal. 4 students would pair off based on their relationships. They could be 2 fraternity brothers against 2 sorority sisters at the same university, or they could be friends at 2 different colleges. Colleges that are sports rivals like UCLA versus USC or UNC versus Duke University would be ideal for audience appeal. Attractive young students in their prime would also add to the appeal. The bids that I received from experienced Upwork WebRTC developers for making an app players could connect with on their smartphones started at $10,000. There was no guarantee that there wouldn't be additional cost because it is a unique app that requires testing. I estimated the cost of interviewing potential players, the fee for a host, and the prize money for 4 to 5 shows to be over $100,000. This is not something I could afford, but it is much less expensive than the budgets for current game shows on TV. There are also marketing issues which an investor or partner with experience and connections in selling shows and attracting sponsors would also affect the budget. Note that if the shows were well produced, they would have lasting entertainment value and enduring revenue potential. I will work with any organization or individual that will partner with me in promoting these apps. You can contact me from any of my websites. The form at Color Coded English also links to my JavaScript certifications and LinkedIn page. If you have any questions or suggestions, I look forward to hearing from you. Thanks.